Good day, and welcome to an episode of my reviewer series for civil engineering topics focusing on fluid mechanics problems. For this situation, what is the approximate height of a certain mountain if a mercury barometer at its base reads 654 millimeters, and at the same time, another mercury barometer at the top reads 480 millimeters? This time, sobrang ikli lang ng problem natin. Pero kung papansinin nyo, onti lang kasi yung given conditions. Walang given na specified method, tapos wala rin masyadong given na values except sa barometer readings. For this kind of situation, dito talaga matetest yung kakayahan natin when it comes to memorizing some standard values and being aware sa application ng concepts. So, to approach this situation, kailangan aware tayo sa idea ng pressure variation with elevation. This concept basically states that as elevation increases, atmospheric pressure decreases. Meaning, as we go higher, mas bumababa yung air pressure natin due to less air mass above. So essentially, this follows a negative correlation with altitude. Now, keeping this in mind, analyze muna natin kung paano nag-work ang mga mercury barometer para malaman natin kung paano natin may utilize to sa pag-solve ng problem natin. Technically, barometers are scientific tools used for measuring atmospheric pressures. And specifically for a mercury barometer, how to read this is just by determining the elevation na magaganap sa mercury column ng instrument natin, wherein yung unit of measurement is usually in mmHg. Kasi in order for us to determine the pressure, unit weight times height lang naman. So given na yung elevation yung magagamit nating height value, tapos gamit lang tayo ng standard unit weight value, madedetermine na natin yung pressure reading kung saan natin nilagay yung barometer. So, moving on to our solution, ang formula na susundan natin is pressure P sub 2 equal to the summation of unit weight times height plus P sub 1. And to keep in mind this formula, mas maganda kung maintindahan muna talaga natin yung concepts. So P2 stands for the pressure at the bottom of the analyzed elevation difference. And P1 naman stands for the pressure at the peak of the analyzed elevation. As for the summation of gamma H naman, this just takes into account yung elements na nagkakos ng pressure change. Or simply speaking, ina-add up natin lahat ng pressures na involved within the given elevation distance. And this makes sense kasi nga, kaya mas mabigat yung pressure sa baba is dahil sa bigat ng pressure mula sa taas. Thus the need to consider all involved elements from above that point talaga. Now obviously, yung H value natin is yung elevation difference natin, which is yung need nga natin i-determine for this problem. On the other hand, since atmospheric pressure ang readings na given tayo, yung unit weight na need natin is supposedly from the air surrounding our mountain mismo. Eh ang kaso nga, wala naman tayong given na unit weight. So for this one, gamit tayo ng standard or common value. So keep in mind, pag di given ang unit weight of air sa problem, ang pwede niyong gamitin na value is 12 newtons per cubic meter or 0.012 kilonewtons per cubic meter. Kasi usually, around that value lang naman yung unit weight if ever na may given. Now, moving forward, determine muna natin yung pressures at point 1 and point 2 by utilizing the barometer readings. As discussed earlier nga, pressure natin is just equal to gamma times height. For this case, gamma ng mercury ang gagamitin natin. And given na wala tayong given na unit weight, gamit ulit tayo ng standard value. So for this one, very usual na ginagamit ang specific gravity na 13.6 when it comes to mercury. And as you all know, in order to determine the unit weight of a given substance, multiply lang natin yung specific gravity by the unit weight of water, which is also another standard value of 9.81 kilonewtons per cubic meter. Tapos, when it comes to the value of H naman natin, 0.1 yung sinusolve natin, so gamitin natin yung given measurement na 480 millimeters. And since ang ginamit natin na unit weight is in terms of kilonewtons per cubic meter, need natin i-convert yung H value into meters. So, magiging 0.48 na siya. Plugging in these values sa pressure formula, we will get a pressure of 64.04 kilopascals. As for the pressure at point 2, same procedure lang ang gagamitin natin. And ang maiiba lang na value is yung height ng barometer reading, which is 654 millimeters or 0.654 meters when converted. Solving for this will give us a value of 87.25 kilopascals. Now that we have our P sub 1 and P sub 2, salpak na lang natin sila sa pressure variation equation natin together with the other solved variables. And solving for the value of H, we would be able to determine the height of the mountain, which is 1,934.5163 or approximately 1,935 meters. So once again, we have finally solved another situation.